Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on gap software. And this video will start a new series, and the series is about pipeline detailed results. So we have a case like this. By the way, we will use existing model from the past series. All right, you can see oil network modeling here. So the case is like this. It is required to investigate the length and frequency of the slugs in the pipeline and the riser that is tied back to manifold B here for the design of an upgrade of the current separation facility. The upgrade is being considered to be conducted in October 1st, 2013, and it is necessary to determine these parameters both on the December 1st, 2010 and on the proposed date. Okay, so we will investigate the length of slugs as well as the frequency of slugs. So hopefully it can be very, very important and enriching learning for all of us. So by the way, once again, we will use existing model. So it's better, to rerun the model first. Maybe there are changes in the model. I'm going to solve the network or resolve the network. Okay, so click on this solve network, run network solver. By the way, the system has already been initialized to December 1st, 2010, and the solve network has already been carried out. Okay, so we will repeat once again the solve network, and we will use the solve network to perform this task. So we will maintain the separator pressure of 200 psig. Next. Okay, so you see this is the result from the past exercise. So I'm going to use optimize with all constraints once again. So let's recalculate. All right, so the computation has been completed. So let's see. So you can see here we have optimizer finish code 3, maximum pressure drop difference, maximum mass balance difference. The highlighted sections of the network solver window inform us of how the calculation progress. So first we have maximum pressure drop and maximum mass balance difference. This tells us what the maximum pressure drop or mass balance difference is at any of the nodes in the system. If any of this exceed the tolerance set in the model, then gap will highlight the nodes in the system, provided this option has been switched on, of course. And we also have last error here. This is the error associated with the solver. It is an indication of whether the model has converged properly. Large errors mean the solver has not converged and the engineer needs to review the input into the model. And you can see our error is to the power of -5, so it's good. We also have last guess. The last guess reports the objective function. For example, in this case, as we are dealing with an oil system and the oil rate is therefore the objective function, and the value reported is the optimized oil rate. So here we have last guess. Okay, and of course, iteration number here. Right, so checking the results of the solve network, we can go to main window, and then let's fly over on our beloved separator. So you can see we have liquid production rate of 8,600. Okay, and you can see the oil production rate and so on and so forth. So this is for our case. If we check on the run prediction, or maybe I'm going to use the file even between this phase, this stage. Okay, so I'm going to use the file of the gap when we perform solve network. So we perform solve network before the prediction, because I don't think I'm going to use this forward. I have different result here, but that's okay. So the main thing of this video is to show you the main highlights or the highlights of the solve network. I'm going to check the model once again to see that I will use the correct model for our series. Okay, so I'm going to close the video here. In the next video, we will check the correct model, and hopefully after that video, we can check the pipeline detailed results. Until then, see you and thank you.